Okay, the last type of bond that we're going to talk about is an ionic bond. And recall when we talked about electronegativity, we said that ionic bonds form because the two atoms have really, really different electronegativities. So one atom is going to be much, much stronger than the other atom. So the stronger atom is going to take the electron from the less electronegative atom, and an ionic bond is going to form. So the atom that takes the electron becomes a negative ion. The atom that gives up the electron becomes a positive ion. And the ions are going to be attracted to each other because opposite charges attract. So the positive ion is going to be attracted to the negative ion, and they're going to stick together and form a crystal lattice. And so let's see what that looks like with an example. Okay, so let's take salt as our first example. Sodium chloride is going to be our first example. So we start with sodium, which is Na. I'm going to change this to blue because I don't like the green. So sodium has an atomic symbol of Na, and chlorine has an atomic symbol of Cl. First thing we want to do is we want to look at the electronegativity values to make sure that this is going to form an ionic bond. And so if I look at sodium, sodium has an electronegativity value of 0.9. Chlorine has an electronegativity value of 3.0. And so what I'm going to do is I'm going to look at the difference. And so I always want to take the larger number, and I want to subtract the smaller number, and I end up with a difference of 2.1. So remember we said that a covalent bond was going to form if the electronegativity difference was less than 0.4. This is much greater than 0.4, so we know it's not going to be a covalent bond. We said that a polar covalent bond would form if the electronegativity value was between 0.4 and 1.7. This is much greater than 1.7, and so we know that this is going to be forming an ionic bond. Okay, so now how do we show what an ionic bond looks like? Well, let's go to a clean page, and we're going to show what an ionic bond looks like. So first thing we're going to do is we're going to draw our sodium atom. Okay, and so if I look on the periodic table, sodium has 11 protons, and it has 12 neutrons. And so the protons and the neutrons go in the nucleus. So 11 protons, that's 11 positive charges. That means that it also has to have 11 negative charges to balance it out. And so it's going to have 11 electrons. So we're going to draw its 11 electrons. So here's 1, 2. This shell is now full, so we go to the next shell. 3, 4, 5, 6, 7, 8, 9, 10. We still need one more, so we need to draw another shell. And here's electron number 11. So that is our sodium atom. And I'm just going to draw Na down here. Now I need to draw my chlorine atom, and I'm going to draw it. Oh, we're going to change it up. We'll draw it in orange. So chlorine has, it has 17 protons, and it has 18 neutrons, according to my periodic table. So 17 protons, that's 17 positive charges, and so I need to balance that out with 17 electrons. So let's draw the 17 electrons for chlorine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we need another shell to put those remaining electrons. 11, 12, 13, 14, 15, 16, 17. So this is my chlorine ion, or my chlorine atom at this point. It's not an ion yet. And so recall when we looked up the electronegativity values, we said that the electronegativity value of chlorine was 0.9, and I'll write it up here so we remember, and the electronegativity value for chlorine was 3.0. So chlorine is actually much stronger than sodium. it's strong enough that it can actually attract one of sodium's electrons and just take it away from him. And so the electron that is going to be affected is the one that's in the valence shell. So what's going to happen is chlorine is just going to take this electron and it's going to move it over. It's going to attract sodium's electron and it's going to move it over here. And so I'm going to show that chlorine has now captured an electron from sodium, which means that we need to go back and we need to erase that electron. Now it's gone from the sodium. So sodium no longer has it. But sodium is happy because, why is sodium happy? Because by losing that electron, what's underneath is a full valence shell. But if I count up the positive and negative charges, sodium has 11 positive charges, but it only has 10 negative charges, which means that now this becomes a sodium ion with a charge of +1 because it has one more positive charge than negative charge. When I go over to the chlorine, because the chlorine stole that electron from the sodium, it now has a full valence shell, so it's very happy. But if I look at the charges, chlorine has 17 positive charges, but now it has 18 negative charges. And so it has an overall -1 charge because it has one more negative charge than positive charge. And so what happens is because these have opposite charges attract, they're going to stick together in a crystal lattice. And when my atoms react, it's not just a single atom that's reacting. There are millions and millions of sodium atoms and chlorine atoms, and they're all reacting. And so, it's going to form more than just one single bond between one sodium and one chlorine. There's actually going to be a whole crystal lattice formed with thousands or millions of sodium and chloride ions in it, and they're all going to be attracted to each other, and they're going to arrange themselves into a crystal lattice, and that's what you see when you look at table salt. Okay, so let's try another example. Let's get a clean page here. Oops. Okay, so now our second example, why don't we do magnesium chloride? So we're going to do magnesium, Mg, and chlorine, which is Cl. So if I look on page 127 at the electronegativity values, I see that magnesium has an electronegativity value of 1.2, and I see that chlorine has an electronegativity value of 3.0. Okay, so when I look at the difference in electronegativities, I'm going to take 3.0 minus 1.2, and I'm going to end up with a difference of 1.8. Okay, and we said that anything greater than 1.7 was going to give us an ionic bond. So this is going to form an ionic bond. Okay, so let's show what that ionic bond is going to look like. Okay, so we're going to start by drawing a magnesium atom right here. Okay, and so magnesium has an atomic number of 12, which means that it has 12 protons, and it also has 12 neutrons in its nucleus. That should be an N. Here we go. Okay, so it has 12 protons, that's 12 positive charges, which means I need 12 negative charges. So let's go ahead and draw its electrons. So 2 in the first shell. Now my first shell is full. I go to my next shell. 3, 4, 5, 6, 7, 8, 9, 10. So I still need to go to another shell because I have 2 other electrons that need a home. So I'm just going to draw them kind of like that so we can see them a little bit better. Okay, so this is my magnesium atom. Okay, now I'm going to draw my chlorine atom. And my chlorine atom, I'll draw it in red. And so my chlorine atom is going to have, I've got 17 protons, I have 18 neutrons, and now I need, because I have 17 protons or 17 positive charges, I need to draw my 17 electrons. So 1, 2, 4, 5, 6, 7, 8, 9, 10, and then I need another shell to put my remaining 7 electrons. 1, 2, 3, 5, 6, 7. So if I look at chlorine, chlorine wants one more electron to fill its valence shell. If I look at magnesium, magnesium only has 2 electrons in its valence shell. So magnesium's choices are to somehow find 6 other electrons to fill its valence shell up, or to get rid of those 2 electrons, so that's what is left is a full valence shell underneath. If I look at the electronegativity values, chlorine has a much higher electronegativity value than magnesium. So chlorine is going to be able to just pull one of magnesium's electrons over. And so what it's going to do is it's going to take this electron and it's just going to steal it from magnesium. So now this electron belongs to chlorine. I'm going to go ahead and I'm going to erase it from over here. And so what happens to the chlorine is now it has a full valence shell. This chlorine atom has become an ion because now it has an imbalance of positive and negative charges. It's gained an electron, which means that it's going to have, it's going to have a charge of -1. Sadly, this chlorine now has a full valence shell. It can't accept this other electron that magnesium wants to get rid of. So what's going to happen? Well, magnesium is going to have to find another chlorine atom to give it to. And again, when we take 2 elements and react them, it's not just one single atom of each that we're reacting. There are millions and millions of atoms in there, and they're going to react in a certain ratio. And so when magnesium reacts with chlorine, it's going to react, one magnesium atom is going to react with 2 chlorine atoms to form an ionic compound. So we need to draw another chlorine atom. And hopefully I have enough room to do that here. I'm going to kind of draw it really tiny. I've got 17 protons. I have 18 neutrons. I'm going to draw my electrons. So now I have another chlorine atom. It also needs another electron to fill its valence shell. So what it's going to do is it's going to steal that electron from the magnesium so that it can fill up its valence shell. And so now this second chlorine atom is also happy. So I have another chlorine. This one has a charge of -1. Now my magnesium, since it's lost 2 electrons, it now has 2 more positive charges than it has negative charges. And this becomes, whoops, using the wrong tool, this magnesium now has a charge of +2. And so now these ions are going to stick together because they have opposite charges, and opposite charges attract. And so when I write the formula for my ionic compound, it's going to be 1 magnesium and 2 chlorines. Because I need 2 chlorines so that magnesium can get rid of both of its valence electrons, and it's happy because underneath it has a full valence shell. So it's happy with a charge of +2, and the chlorines are both happy with a charge of -1. And I formed another ionic compound. It's going to form a crystal lattice, and this is another example of a salt. So hopefully that gives you a clearer understanding of the 3 types of bonds that we talked about: covalent bonds, polar covalent bonds, and ionic bonds.